Following on from the previous video, our aim here is to try and prove this, is to try and prove that this is exactly the same as this here. And the way we do that is to write this a here as a number to the power of something. So we would then later put this into here, and then you can see then you will see that for some reason it cancels each other out and it becomes nice and neat. So the trick here is to rewrite this a here as a to the power of something, and then put this something into there, and then later it will tidy itself up. But before I show you how to do that, there are a few things that I need you to understand first. So when given a statement like this, remember we've done several exercises on this. We can convert this into this, because when given this here, we've done several examples on this already. Well, when given this here, you can translate it to this, because if you think about it, when given this, your eyes zoom into the base here, so it's z to the power of what equals a, and then if you look over here, a to the power of, well, you can see that when you put n into here, then this thing equals to a. My point is that when given this here, we can always translate to this. When given this here, we can always translate back to this. So these two are pretty much the same. Okay. And the other thing that I need you to understand is that when given a number, any number, you can always translate it to something to the power of another thing. Because if you look at hang on. So when given a number, you can always translate it to something to the power of another thing. Because hang on, if you look at hang on, y equals 2 to the power of x. Okay, if you look at this graph here, if you give me any number a, let's just say, I don't know, let's just say 78 here, I can rewrite 78 as 2 to the power of something, because it will exist. There will be that something here. And then if you look at what y equals 3, hang on, yeah, if you look at y equals 3 to the power of x, if you give me any number, let's just say 78, then it's possible to write 78 as a number, as 3 to the power of something, because it does exist. This something here exists. If you look at y to the power of 4 or y to the power of 10, 10, y equals 10 to the power of x, say. If you look at this graph here, if you give me any number, I don't know what, can I say 70, 78? Okay, yeah, if you give me any number, 78 here, it is possible. You see that there is that something. I can rewrite 78 as 10 to the power of something. That something here exists. So my point is that any given number, you can rewrite it as something to the power of another thing. Okay. And the other thing I need to remind you about is that if you have log to the power, log base z, and then z to the power of n here, then this becomes n. We've done several examples on this already, because when you translate this here, your eyes are zooming to the base here, z to the power of what will give us this thing here, z to the n. You see, if you put n into here, then well, that n there's this. My point is that when you see something like this, log z to the power of n, pretty much in a way it's a bit like that. Well, anyway, bear those things in mind. In the next video, I will show you why this is equal to this. Okay.